Good day, ladies and gentlemen. My name is Honorable Maji Solomon. Right now, I'm going to treat Charles Law in the field of chemistry. Chemistry. Topic: Charles Law. Charles Law states that the volume of a given mass of gas is directly proportional to its absolute temperature at constant pressure. All right. Charles Law states that the volume of a given mass of gas is directly proportional to its absolute temperature at constant pressure. Pressure. This word is called pressure, not pressure. It is not called pressure. It is called pressure. International Pronunciation of Alphabet, IPA. If you check the IPA, It is called pressure. Check the IPA very well. If you check the IPA, you will notice that this word is called pressure, not pressure. It is not called pressure. It is called pressure. Okay. Charles' law says that the volume of a given mass of gas is directly proportional to its absolute temperature at constant pressure. V1 all over T1 equals to V2 all over T2, where where V1 and T1 are the initial volume and absolute temperature of the gas. V2 and T2 are the final volume and absolute temperature of the gas. absolute temperature equals to absolute temperature equals to centigrade temperature plus 273. Zero degree Celsius. It is called Celsius, not Celsius. It is called Celsius. Check the IPA. It is called Celsius. 0 degree Celsius. This C stands for Celsius. It stands for centigrade. Centigrade is an old-fashioned name for Celsius. You can either call it Celsius or centigrade. You can either call it centigrade or Celsius. 0 degree Celsius equals to 273 Kelvin. K stands for Kelvin. K stands for Kelvin. This K stands for Kelvin. Okay? I'm going to set a question that will bring about calculation in my example. Example 1. Example. It is not called example. It is called example. Example. Example 1. Example 1. the volume of example 1, the volume of a given mass of gas is 238 centimeter cube at a temperature of 42 degrees Celsius. Calculate its volume at 87 degrees Celsius. Pressure remains constant. What are you going to do? What will you do? Solution. Okay? Absolute temperature was to centigrade temperature plus 273 plus, that is to say, we are going to convert (42 degrees Celsius) into our absolute temperature. It's in degree, it's in degree Celsius. We are going to convert it into our absolute temperature. Convert it to Kelvin. Convert degree to degree Celsius to Kelvin using these numbers 2, 7, and 3. Convert this number 42 degrees Celsius to Kelvin using these numbers 2, 7, and 3. Convert 87 degrees Celsius to Kelvin using 273. Look at it. Absolute temperature equals to centigrade temperature plus 273. Now, all right. V1, our initial volume is 238 centimeter cube. Okay? Our initial temperature. Our initial temperature equals to 42 degrees Celsius. our our final volume was not given. I have question mark. Question mark. Our final volume was not given. I have question mark here. Our final temperature. Final temperature is given. Our final temperature is given. To be 87 degrees Celsius. Okay. Before we can go into calculation fully, before I can go into calculation fully, I have to convert this 42 degree Celsius into Kelvin. From 42 degrees Celsius to Kelvin. Using these numbers, 2, 7, and 3. 273. 273. I'm going to use these numbers. 2, 7, and 3. 2, 7, and 3. 2, 7, and 3. Now, what am I going to do? I'm going to convert this, and this, before I can go into the calculation fully. $273 plus plus 42 plus 42 degree Celsius. I'm converting it to Kelvin. Kelvin. $273, you are to use these numbers, 2, 7, and 3, in converting 42 degrees Celsius to Kelvin. 273 plus this 42 degrees Celsius will give you 315 Kelvin. 315 Kelvin. So our initial absolute temperature, our initial absolute temperature is 315 Kelvin. All right? Okay. What of our final absolute temperature? Okay, I'm going to convert it now. Final absolute temperature. 273 plus 87. 87 also 360 Kelvin. Alright? Okay. Now I can go into the calculation fully. 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 Into the calculation fully. I can go into the calculation fully. I can go into the calculation fully. V2 is not given. Final volume is not given. We are looking for our final volume, V2. We have our V1 to be 238 centimeter cube. We have our T1. V1 means initial volume. Initial volume. T1 means initial temperature. V2 means final volume, and it is not given. A final volume is not given. T2 means final temperature is given. It has been converted to 360. Initial temperature. Initial temperature is given. Look at it, 42. It has been converted to Kelvin. We have 315 Kelvin. Okay. Now, what is the next line of action? We are looking for our V2. V2 is not given. V2 is not given. Final volume is not given. We are looking for our V2. V2 is not given. V2 is not given. V2 is not given. We are looking for our V2. V2 is not given. V2 is not given. I have to go into calculation. I have to go into the calculation in order to find out our V2. Okay. Since V2 is not given, we are looking for our V2. I am looking for my V2. V2, I'm going to make V2 as the subject of the formula. V2 equals to V1 T2 all over T1. V2 is what I'm looking for. V2. V2 equals to, look at the V2, it's not given. Then I'm going to make this V2 as the subject of the formula. V2 equals to V1 T2 all over T1. V1 T2 all over T1. V1 was given. T2 was given. T 1 was also given. Okay. What do we do? Alright. V2 equals to V1. Our V1 is what? Our V1 is 300. Our V1 is 238 centimeter cube. V1 equals to 238 centimeter cube. 200. Look at it here. V1 T1 means V1 times T2. V1 T2. V1 T2 means V1 T2 means V1 times T2. Okay. V1. Our V1 is 238. 238. 238. Okay? 238 centimeter cube times our T2. Our T2 is given. Our T2 was given. Look at it. 360. 360. 360. Okay? All over T1. All over T1. 360 Kelvin. All over T1. All over T1. Our T1 was given also. Our T1 is 315. 315. 315. 315 Kelvin. V1 means initial volume. T1 means initial absolute temperature. T2 means final absolute temperature. V2 means final volume. And our final volume was not given. We are looking for our final volume. For us to get our final volume, look at it now. V2 has become the subject of the formula. V2 equals to V1 T2 all over T1. V1 was given. T1 was given. T2 was given. Look at them. V1, look at it. 238 centimeter cube. T2, 360 Kelvin. T1, 315 Kelvin. What do? V2, you multiply this by this. Multiply this by this. I'm not going to use Kelvin at the end of my calculation, so I have to remove them. I'm not going to use them at the end of my calculation. I have to remove Kelvin because I'm not going to use them at the end of it all. I'm looking for V2. I'm going to make use of centimeter cube. Centimeter cube. Okay. Now, 238 times 360. The answer is 85,680. All over this 315. 238 times 360. The answer is this. 85,680. all over this number 315. V2, when we divide this number by this 85,680 divided by 315, the answer will be 272 centimeter cube. QED. Quote error demonstrated. The problem has been solved. I have succeeded in getting my V2. My V2 is 272 centimeter cube. My V2 is 272 centimeter cube. Thank you so much. Thank you.